Okay, today we're going to focus on trigonometric equations. This past few lessons we worked on inverse functions, and also we solved a little bit of equations, but today we're going to spend this entire lesson focusing on solving different trig equations. So basically we're just going to be working through a good bit of examples, and our first example is going to be 4 sine of theta plus 7 equals 9. Okay, so this is just our first given equation, and we want to find the thetas that satisfy this. Now let's keep in mind our range. So first of all, sine of theta, this is our basic sine function, not the inverse function that we've been focused on, but our basic one. And we're going to remind ourselves that that is between 0 and 2 pi. So one trip around the unit circle. So sine theta. Alright, so the first thing we want to do is we want to treat this just like basic solving equations. So if we're trying to get this by itself, the first thing we want to do is subtract 7. Let's try to move as much as possible to the other side. So I have 4 times the sine of theta is equal to 2. Now if we treated this just as an x, and this was 4x minus 4x equals 2, what would be our next step? Divide both sides by 4. Good. So if it helps you to zone in and treat this just as an x, so until we get to our last step, that's something you can do if it helps. So now we're saying let's divide both sides by 4. Whatever you do to one side, do to the other. So our sine of theta is equal to 2/4 is going to simplify to 1/2. Okay, we want to know what thetas does the sine of theta equal 1/2 have the 1/2 value. So what is the sine of theta? It's your what? Your y value. So where does that occur? Pi 6, here's the y value of 1/2. So I'm going to make a note. I'm going to say pi 6. And anywhere else? Sine of theta equals positive 1/2. Right here, 5 pi over 6. So the answers are pi over 6 and 5 pi over 6. Now that's not an ordered pair. This is just a list of answers. So these thetas, these values for theta, satisfy this, meaning pi 6 and 5 pi 6 will satisfy our original equation, and they are in our interval from 0 to 2 pi. All right, our next example is 8 cosine squared theta is equals to 6. Cosine 0 to 2 pi. Okay, just to remind ourselves. Now let's, first of all, we want to get cosine squared by itself. So what would we do with this 8? We divide both sides by 8. Good. So divide this side by 8 and this side. So that would leave us with cosine squared theta is equal to, let's go ahead and reduce that now. All right, that does not give us theta by ourselves yet, so we got to do something about that square. What do you think we'll do? Take the square root. Yes, so whatever you do to one side, you want to do to the other. Square root both sides. So a square root is going to undo a square, so to say, and that would just leave us with, let me do that in blue, cosine theta is equal to, now when you take a square root, don't forget you get plus or minus the square root. First of all, the square root of 3 doesn't simplify, so I'm going to get the square root of 3. But what about square root of 4? It's just positive 2. Good. So we're looking for, we have to have two different values. So first of all, where is the cosine of theta equal to the square root of 3 over 2? That's one of the things we're looking for, but we also have to consider where the square root of theta is negative square root of 3 over 2. Okay, so first of all, let's do this positive. The cosine theta is equal to the x values, so we want to know where the x values are positive square root of 3 over 2. Well, here's the first one, pi 6, so this one's going to be pi 6. And any more for positive square root of 3 over 2 for our x value? 11 pi over here. Good. 11 pi over 6. Okay, these two theta satisfy this first condition. Now let's find any ones that have negative, any x values of negative square root of 3 over 2, which is going to be negative values right here, 5 pi over 6, and 7 pi over 6. Good, so look at 7 pi over 6. All right, so basically if I list all the solution answers, it would just be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6 as all the answers, all the thetas that satisfy the original equation. Now, these are just in order. They don't necessarily have to be. As long as we include all four of them, I just put them in order. So this is the set of all the thetas that satisfy 8 cosine squared theta equals 6. Alright, our third example is going to be 8 sine squared theta minus 4 equals 0. Sine is defined, sine is from on the interval from 0 to 2 pi. Okay, let's go ahead and start solving that. So first thing we want to do is add 4 to both sides. So then that will be 8 sine squared theta is equal to 4. And now our goal is to get this term by itself, so what do we do next? Good, divide both sides by 8. Whatever you do to one side, do to the other. Good, that leaves us sine squared theta is equal to, this simplifies to 1/2. Once again, we're going to undo a square term by taking the square root of both sides. That will give us sine of theta is equal to, what's the square root of 1? Just 1, and then square root of 2 doesn't simplify, which is this, but let's go ahead and rationalize that. Some unit circles have their values in this, but we've practiced rationalizing this whole time, so just let's multiply by the square root of 2 over the square root of 2, and that's the same thing as square root of 2 over 2. Now we must remember our plus or minus because we took the square root of each side. So it's similar to what we did a minute ago, but we're going to say, well, we want to know when the sine of theta is positive square root of 2 over 2, and we also want to know all the theta values when it's negative square root of 2 over 2. So let's pull our unit circle up. Move this over here. Go ahead and be checking those values. So the sine theta, that's where the y value is square root of 2 over 2. Where does that occur? Positive pi over 4. Good. So for sine of for positive, we have pi over 4, and anywhere else? Yeah, right here, 3 pi over 4. So we have 3 pi over 4. All right, let's now find the negative values, y values of negative square root of 2 over 2, which are going to be right here, 5 pi over 4, and right here, 7 pi over 4. So let's jot those down. So 5 pi over 4, and also at 7 pi over 4. So if we did the entire list of all the solutions, it would be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, so this is all of our solutions. Okay, our next example. First of all, sine, let's remind ourselves, is 0 to 2 pi. We're going to look here. What's different about this one in respect to the other ones? There's something in here with the theta, where if we just skim back to the last one, theta was by itself, theta was by itself, theta was by itself. Well, here, it's 4 times theta. So this one we have to approach a little bit different. So before we start working with this, we want to know, where is the sine function equal to 1? Okay, so where is the sine function equal to 1? Pi over 2, right? Y value, positive 1. So that occurs at pi over 2. So let me write this so we have a trail. So sine of 1 is equal to sine value at pi over 2. Okay, so what we have to do is this is not just theta, that's 4 theta. So we're going to account for that by saying, well, 4 theta is equal to pi over 2. But let me go back before we say this, before we go a little bit further with this. Sine of theta is 1 at pi over 2, but not just pi over 2. Pi over 2 in our 0 to 2 pi, but technically, what is it? Wouldn't it be all the multiples as well? All the multiples of period of 2 pi, which if I started here, and then I went all the way around, that's another one, went all the way around. So when I put the notation plus k times 2 pi, that means all, k just means multiples that I'm willing to go around 2 pi times. So you've seen a little bit of this notation before. All that means is if the sine of theta is equal to 1 here, and if I'm willing to go around 2 pi, which is one trip around the unit circle, I'm right back at sine of theta equals 1. And if I were to do it again and do it again, the k just represents multiple times all the way around. Okay, so when I'm doing that, I'm going to say, well, the sine of theta is equal to 1 as many times around as we want to go this location. So when I say that, I also have here plus 2k pi. Now, all I did was move the 2 to the front because I'm going to simplify these numbers. 2k pi, k times 2 pi, it's all commutative there. So I'm going to say the sine of theta is equal to it at pi halves and as many times around the unit circle, 2 pi multiples of period of 2 pi as I want. Okay, so now we're here and we want to get theta by itself. So what do we do with theta to get theta by itself? Divide by 4. Okay, so then that's just going to give us theta is equal to, well, pi over 2 divided by 4 is the same thing as multiplying by the reciprocal, which would be 1/4, which that simplifies to pi eighths. Now here, the reason why I put the 2 out front is so that these reduce easy, and that's just going to give us, let me put it in black, k pi over 2. Alright, so now what we want to do is let's pick some values, find some solutions for this equation up here by letting k equal certain values. So this could be any values. Let's just say let's let k equal negative 1, 0, 1, 2, and 3. So for k equal negative 1, theta would be pi eighths plus k, which is negative 1 times pi over 2. Which this would just be pi eighths plus negative pi over 2. Get a common denominator right there or use your calculator to evaluate that. So would give us negative 3 pi eighths. Let's do the same thing for k equals 0. So basically we plug the value for k equals 0 into this. So theta is equal to pi eighths plus, this time we're going to use 0 times pi over 2. Which this one's a pretty easy one, right? So what does this just become 0? So pi eighths plus 0 is just going to be pi eighths. I want you to do the rest. Okay, so when we just pick certain values for k and plug it into our solution, then we could see we get negative 3 pi 8, pi 8, 5 pi 8, 9 pi 8, and 13 pi 8. Now we can keep going on and on like k equal 4, k equal 5, k equal 6. We could just keep going, but we want the solutions that are in our interval from 0 to 2 pi. Is this in 0 to 2 pi? No, because it's a negative value, so I'm not going to use this value, but this one is. Pi 8s, 5 pi 8s, 9 pi 8s, and 13 pi 8s are all within our 0 to 2 pi area. So now if I was to test a 4 and put a 4 right here, what's 4 divided by 2? 2 pi. Well, 2 pi plus pi over 8 takes us out of the 2 pi, so that we could see we don't necessarily have to go any further. So our solutions are going to be these values here. So pi 8s, 5 pi 8s, 9 pi 8s, and 13 pi 8s.